Okay, so I'm going to do number 10 right here on the review sheet. We want to find the domain and range of the graphs that we have and determine if they're functions. Let's notice first of all that this graph, let me turn on my draw feature, does not pass the vertical line test. The vertical line goes through it twice, so it's not a function. Now let's remember to determine if they're one-to-one, we have a horizontal line test. Well, by the same token, if I run my horizontal line through it, it hits twice, so it's not one-to-one. All right, let's get the domain and range. If we think of squishing the circle, remember nothing crinkles or moves to a different place. Everything compresses straight down onto the x-axis. We would have from 0 to 6 covered. And I know those numbers are pretty small, but our domain would be from 0 to 6. And those are points on the graph, so we need square brackets, 0 to 6. Now let's think about if we squish the circle over here on to the y-axis, the lowest value that will get covered will be right here, and that's actually -3 because it's between the -2 and the -4. Everything in between would get covered, and then our highest value would be right here at 3. So from -3 to 3 would get covered in the range. Well, -3 to 3. Again, square brackets because those are actually on the graph. All right, now let's go to our second graph. Let's notice no matter where I try to draw a vertical line, it's only going to hit this thing once. So this one is a function. On the other hand, if we do the horizontal line test, we hit this thing twice, so it's not one-to-one. Now let's get our domain and range. If we think about squishing this thing onto the x-axis, now let's remember this is going forever, this is going forever, so it's really going forever outward and ever outward. Everything on the x-axis is going to get covered. So the domain is -infinity to +infinity. Make sure you put open brackets next to your infinity symbols. Now the range, on the other hand, if we think about squishing it onto the y-axis, there's not going to be anything beneath -4. So it starts at -4, but then these ends are going up forever. So it goes up forever. So our range will start at -4, which is actually a point on the graph, so we want a square bracket, but it goes to infinity. All right, now let's look at the last of these. All right, so we have some transformation of x cubed here. All right, so let's notice, though, that both ends we can assume go forever. So even though this is going outward forever to the right and this is going outward forever to the left, it looks like it's not going far, but it is. It's just doing it very slowly. So this really would, if we squished it down on the x-axis, cover everything. And I'm talking about domain. I need to talk about function here, but I'll come back to that. So the domain is -infinity to +infinity. Let's get range and we'll go back to whether it's a function or not. All right, so range, let's notice if we squish it on the y-axis, it's going to go down forever and it's going to go up forever. So the range is also -infinity to +infinity. All right, now I didn't determine whether it was a function, so let's notice if we do the vertical line test on it, no matter where we draw a vertical line, this thing only goes through once. So it is a function. And by the same idea, if we do our horizontal line test, every horizontal line we try to draw only goes through it one time. So it's one-to-one. All right. let's see, we've got a little bit of time. Let's see if we can do at least part of 11. So I'll do 11a. So let's find the inverse of 2x minus 9. Let's remember our steps. First, change f of x into y. Then switch your x's and your y's. Then solve for y. So let's add 9. We get x plus 9 equals 2y. And then let's divide by 2, and we have y by itself now. Now, last step is to put the functional notation, and we always want that in front, not in back. And of course, we can always switch the sides of the equal sign. So our f inverse is x plus 9 over 2. All right, now let's do 2x squared minus 8. Now remember, this right here, you really don't need to pay attention to. It's just making the function that's not normally 1-to-1 into a 1-to-1 function. So we can actually ignore that. Let's just deal with 2x squared minus 8. Let's see if I've got room here. I'm going to change f of x to y. Let's switch the x's and the y's. And let's solve for y. So add 8. We'll get x plus 8 equals 2y squared. Let's divide out our 2 that's still with our y squared. So divide it out. Now, we still have a y squared. To get rid of a y squared, let's recall we're going to do a square root. And we don't have to worry about positive and negative because that 1-to-1, that little x greater than or equal to 0 part that was in our original thing right here made sure that we are only going to worry about the positive square root. All right, and then let's change it into the f inverse notation, and we've got it. Okay. All right, and I'm going to end this video there. I'll come to 11c and d in the next video, just simply because I need to stop the video for the moment.